this video we'll combine a large data set of the incredible southern galaxy Centaurus A. This was taken using the Chile 1 24-inch planewave telescope fitted with a QHY 600M CMOS camera. Centaurus A is a relatively nearby and bright galaxy, so even short data sets such as this one, which contains just 4 300-second sub-exposures, produces very nice results. However, Centaurus A isn't just a single galaxy but a snapshot of a galactic collision between 2 or possibly 3 galaxies. The primary galaxy is a massive elliptical, but at some point a younger spiral galaxy is ploughed into it, creating a disturbed maelstrom of activity. Surprisingly, there is very little interaction between each galaxy's stars, as they are just too far apart from each other. What we see here is a gravitational interaction between the dust and gas of the spiral galaxy, which has been very badly shredded, to collapse and trigger new bursts of star formation. A short data set reveals all this mayhem very well, but there is a hidden treasure lurking in the background that shows a very different view of this galactic confrontation. Our deep data set will allow us to easily reveal incredible shells of stars that have been ejected from the collision. When I see these, I visualise the spiral galaxy careening into the elliptical dead centre, scattering the stars, and imagine a scenario like when a stone is dropped into a pond, causing concentric waves to spread out from where the stone impacts the water. Let's start off by loading all the LRGB sub-exposures into AstroPixel Processor using the Load and Light buttons. The chosen images are shown in the file list below and are colour-coded for convenience. APP is my favourite software for calibrating, aligning and stacking images. The data have already been calibrated by Telescope Live, so we can jump straight into the Integrate menu. Select Integrate per channel so we can create a master stack for each of the LRGB filtered shots. A lot of the settings shown here are default, but I'll scroll down slowly so you can see the values I've chosen. At the bottom we choose our save directory and then click on the Integrate button, choose a file name and then press OK. We can sit back while APP does the business. This will take a while, so I'll speed up the video to keep things moving. The file list is populated with the new LRGB master frames. We can click on these individually to view them on screen. Okay, these all look fine. Let's create an RGB master frame now by clicking on the Tool button and then scrolling down to Combine RGB. From here, make sure that RGB1 is selected, then click on the Add Channel button to select the 3 RGB master frames. Click the Recalculate button and the combined file will shortly appear on the screen. Click on the top left Save button to save the RGB file to our chosen directory. Now I'll switch over to PixInsight, as I'd like to apply the remarkable Blur Exterminator plugin to our datasets, and this can only be carried out in PixInsight. First I'll apply BX to the master luminance frame. Here you can see the values I've chosen. For brevity I've left the automatic PSF selected. I'll apply these settings to the image. Once completed, we can zoom in and see that both the stars and the galactic detail have improved a huge amount. At this point, I save the processed image as a 16-bit TIFF file, and then to keep things moving, I'll use the same BX settings on our RGB file. Good, that looks really nice. This will also be saved as a 16-bit TIFF file. Now I'll switch to Affinity Photo to start working on the two files. There's a slight tonal mismatch between PixInsight and Affinity, so I'll adjust both images using the Levels tool. Next, I'll copy the RGB image to the clipboard using Ctrl+C. We have to convert the monochrome luminance image to RGB using Document, Convert, RGB 16, and then paste the RGB image from the clipboard. To blend the images together as an LRGB file, select the top layer and choose Colour from the drop list. This is looking really nice already. I'll save it using Affinity's layer format, and once done, the image can be flattened into a single layer for the next part of the processing. The first step is to open the image in PixInsight so we can remove the stars from the image using the Star Exterminator plugin. It's possible to do this in Affinity, but it's quicker and easy to do it here. When completed, we have two images on screen, the stars only image and a starless version. I'll save both of these . And then switch back to Affinity. With the starless version active, I'll first darken the sky background slightly using the Levels menu. As always, I'll leave a little bit of headroom on the dark end of the histogram. Let's have a sneak peek at the faint detail in the sky background. Click on the tone mapping persona at the top left of the screen. As always, the menu will overprocess the image, so we back the tone compression slider back to 0. If I use a value of around 45, the star shell should really pop out of the background. Note the better visibility of the curious jet of material pointing radially away from the galaxy's core. I hope that you agree that this technique has helped to show the star shells with a lot more clarity, but the procedure has overprocessed the core detail. We can deal with this by taking a slightly different approach. I'll cancel the tone mapping for now and go back to the original image. We know that the procedure just used worked brilliantly on the faint star shells, so let's create a mask to protect the galaxy core. This is very easy to do by first creating a duplicate layer. To keep track, I'll name the top layer Sky and the bottom layer Galaxy. Click on the Erase Brush tool, ensure that the hardness setting is set to 0. Use a brush size that covers the galaxy and click on the sky layer to make it active. Draw the brush over the galaxy to effectively erase it from the sky layer. You can check what's happening by clicking on the galaxy layer and unticking the visibility box. It's a good idea to save this work as we go along, so I'll use Save As to save the image with the multiple layers. Now we'll switch back to the sky layer and re-enter the tone mapping persona. Reduce the tone compression slider to 0 as before and choose a value of around 45% for the local contrast slider. Note on screen the reappearance of the star shells and that the protected or masked area of the galaxy is not affected. Click on Apply to continue, and I'll save the image again. Next, I'll copy the LRGB stars into the clipboard and then paste them in as a new layer named Stars. We can blend them in using the Add Blending mode from the Layer drop list. Before continuing, I'll crop the image slightly to remove the edge artifacts. The image looks a little bit bright, so click on the sky layer, hide the other two layers and use the levels menu again to darken the sky background. Okay, this is starting to look really good now. We can possibly draw out more structure in the shells, so deselect the other two layers temporarily and click on the Filters button and then scroll down to Sharpen and then Clarity. I found a value of around 20% works really well. Both the tone mapping procedure and the clarity tool usually introduce some noise into the sky layer. To address this, we'll use Noise Exterminator. This can be done in Affinity, so I'll select the sky layer as before and run Noise Exterminator. Continuing, we can now work on the galaxy layer. I'll start off by boosting the colour a bit using the Vibrance tool. Now we can use the selective colour menu to boost the colours a bit more, well, selectively. We can enhance the red H2 regions as well as the blue stars. This is looking good, but if required we can run this procedure again. Once done, we can bring back the sky and star layers. I'm happy with this, so I'll save the image again. I'm going to apply a small amount of sharpening to the galaxy layer using the tone mapping tool again. This time a small value of 10% should work well. Now we can bring back the other layers. We're almost done here now. You can boost the colour of the stars by using the Vibrance tool on just the star layer. One final step we can apply is to moderate the sky background selectively. With just the sky layer visible, we can see a brightness variation at top right. This can be moderated by going into the Develop persona and creating a gradient. The red mask shows where and how strong the gradient tool will apply. I'll adjust the black point slider as well as the vibrance or saturation sliders to remove the slight reddish tone from the sky background. Click the Develop button to complete the procedure. With a more even background now, I'll give a final tweak to the black point. That's it, we're just about done now. To finish, I'll flatten the image and paste it on top of the original LRGB file so we can compare the two. With both layers selected, we can use the Align Layers by Stars tool to align both layers. Hiding the top layer allows us to see the before and after versions.